Sir, recording started.
Yes. So very good morning to one and all present here. I am Dr. Muhammad Iqbal, FIE, member of the Katangulathur Local Center. On behalf of the Katangulathur Local Center, I welcome you all for this part of centenary celebrations, that is 100-hour IEI Tamil Nadu Local Center Techno Carnival based on the theme Sustainable Developments of the Nation, the Role of Engineers. I welcome Dr. T.M. Gunaraja, FIE, Centenary President, IEI, Tamil Nadu State Center, Dr. P. Nallatambi, FIE, Organizing Secretary, Tamil Nadu State Center, Engineer S. Kannan, FIE, Chairman, IEI, TNSC State Center, and Engineer K.N. Sivaraja, MIE, Honorary Secretary, IEI, TNSC, Dr. P.T. Ravichandran, FIE, Chairman, Katangulathur Local Center, Dr. S. Dhanlakshmi, MIE, Honorary Secretary, IEI, Katangulathur Local Center. I also welcome our Head of the Department, Dr. M. Charladan, whose constant support and motivation helps us to organize such events. And my warm welcome to Dr. M. Piramanandam, Senior Engineering Manager, Mechanical, R&D, ESAB Engineering Service Division, Irungattukotte, Chennai, who is going to deliver a lecture on role of computer-aided engineering for product sustainability. I also welcome Dr. R. Sendil, Associate Professor, Department of Mechanical Engineering, SRMIST, Katangulathur, for delivering a lecture on thermal energy storage for solar collectors. I welcome all my fellow colleagues, Dr. M. Kamaraj, Dr. A. Vijaya, Dr. V. Madan Raj, and Dr. N. Harshavardhana. And also my hearty welcome to all the participants who has registered for these events. Thank you.
Thank you, sir. Thank you for your wonderful introduction, sir. Now, now I'll give the introduction about the speaker. Okay, first speaker, who's none other than Dr. Paramanandam. Okay, to be a good speaker, we have to listen first. Now we have to be in the state of listening because we have one of the eminent person, eminent and dynamic personality, Dr. Paramanandam, and Dr. Paramanandam completed his master's from College of Engineering, Indi, and PhD from Anna University in the area of adiabatic engines. His responsibility in ESAB includes leading the mechanical R&D team, developing the new product, FEA and CFD specialist, experimental and validating the test results. He is also a member of MIE, member of Institute of Engineers, and life member of Combustion Institute. He has more than 20 research papers, and he has delivered more than, say, 50 research talks. I invite or I welcome Dr. Paramanandam to give a wonderful talk on the area of sustainability. Sir, I welcome you, sir.
Thank you for warm introduction, sir. Can we start this session?
Sir, 1 minute, sir. Now I request our secretary, ma'am, Dr. S. Dhanlakshmi, to say a few words about this 100 hours of IEI TNSC Techno Carnival. Ma'am, Dhanlakshmi, ma'am. Can you hear me, ma'am? Dhanlakshmi, ma'am. Yes, sir. We will call her after some time, sir. Sir, you can continue, sir. Thank you.
Thank you. Yeah, no problem. Before starting the session, I would like to thank the organizing committee of Institution of Engineers and SRM Institute of Science and Technology for inviting me to present lecture on role of CAE for the product sustainability under the theme of sustainability development for our nations with our engineers. So in today's session, we can look into like what is sustainability and how can we consider the sustainability in the way of making the process or developing the new product or upgrading the existing product with the introduction of computer-aided engineering, how can we make use of the existing technology to bring the sustainable product, and also how it is working. And we can summarize with some of the case studies of CAE, how it can minimize the cost, time, and other resources in the development process. Sustainability, everyone knows what is sustainability. Sustainability, it is simply the things that should exist for longer duration without degrading or without any negative impact on the planet. We can also say like it's something that can be continued without harming the environment mainly. We will also say resource is sustainable if we use the resource in such a way that it is not depleting the things for shorter or longer durations. In summary, we can say sustainability, if it is not affecting the human beings in the way of affecting the environmental conditions, consequently that will affect the economic conditions. If you see in this smaller image where the sustainability rests in the middle of environment, economics, and society. So we all know the product design and the development process mainly. Like if you take anything, any development or product designs, simply bringing a solution for addressing or providing a solution to the customers. So it may involve like a modification of existing product or bringing entirely a new product to the market. Most product designs falls under either demand pull or invention push innovations. The demand pull will happen if there is a gap in the market to solve the customer problem. Invention push, introducing the new technology and lead to the process as well as for the product. In both the cases, demand pull or invention push, the sustainability is the global concerns for the present demand pull and invention push. If we design any product, that should meet the standards and regulatory requirements of different regions across the globe actually. If you take any product designs, in the customer perspective, they will exit for longer durations without having premature failures, without delivering defects, and delivered on promised time. That will be the motto for a customer. But for a designers or for an engineers, the considerations are meeting the critical requirements, primary users, primary requirements, as well as the secondary requirements, and critical to quality, critical to reliability, efficiency, safety, eco-friendly, and durability, reliability, everything actually. So if you take these critical parameters, the first parameters, now the all regions and the regulations are focusing on critical to efficiency. Only the power aspects already started. In 2023 onwards, in some countries and some regions, we will not be able to deliver the product if efficiency is not meeting 80% in electrical aspects. Similarly, for other things also, in coming days, we will have the statutory and regulatory requirements. If you take NPD process development, the first thing is if any market product requirement specification comes, the engineer's role will be like developing the concept through idea generations. We will have so many concepts. From that concept, the next thing is screening the concept, then validating the concept. Then we will analyze the business, whether if we implement that concept we will able to succeed on time, budget, cost, and also whether we will satisfy the customers for the solution. Once that analysis is made and the break even finalized, and we'll go for the product development, and the testing and the commercialization will take place. In each stages, we need to consider the sustainability actions. If you take earlier designs or the product development process, it is not focused much on the sustainability, but nowadays it is very important to meet statutory requirements. So in each stage, we need to consider whether I can able to meet the statutory requirements through this concept or not. So that is the importance of considering sustainables in each stage of product development. If you take product life cycle management, like from the design thinkings to selection of material, process for the manufacturing, product validations, and the distribution, and the end users requirements. In all these key steps, we have to consider the sustainability. And also it is like a cross-functional collaborations and delivery. Sustainability is not just an individual decision. The first thing is design for environment. In design for environment, if you take these yellow highlighted things, rest with our engineers, and the standards and legislations from the body of different regions, and also safety and the environmental requirements, then our business output. This is an example of how can we use our engineering techniques in order to bring a sustainable product in the material selection, and introducing the technology for my customer requirements, and selection of fuels, and selection of concept and other material stability conditions, and also the engine output and the efficiency and emissions. This is just for understanding how can we use the techniques for sustainable development. If you take a product life cycle from the start of concept to delivery of the things to customer, and also making the like a product care and maintaining the product throughout the life cycle. So in the start of initial stage itself, we need to list out what material I am going to use and what concept, what technology, how it is going to distribute it to customer, and how I am going to measure the performance, as well as the measure the customer satisfaction and the recyclability of the product. Everything need to be considered from the start of the process. The degree of sustainability will be more if I consider the beginning of life itself on the sustainable aspects. So all 6 M's need to be considered in the start of the product development: man, machine, material, methods, milieu, and how I am going to measure or estimate the things during the customer end. Summary of this PLM consideration is, it's a closed loop cycle from selection to end user applications. Everything should be in the consideration of reusing, recycled, or remanufactured rather than scrapping. In the 3 key steps like design and development, manufacturing, service, our engineering inputs will be design, evaluations, estimations, validations, rest into this design and development from the collection of manufacturing requirements, collection of product specifications, and quality function evaluations. Everything we can put into more on this design and development stages, and we will arrive at a final workable concept and workable prototype. during this design and development, where this is the key place we can use our computer-aided engineering. Here we can see the different cross-functional teams' involvement in the product life cycle. This is the area where the CAE will be more interactive and more fruitful results we can arrive if you introduce the CAE. In this design stage, key things that we need to consider for sustainable things are the manufacturing aspects, design for manufacturability and modularity. The modularity concept will be best suited if I have planned to expand in the future. Design for assembly and design for S like serviceability, whether I can able to make easily servicing things, and I can able to source the components or elements of product throughout the global, and whether each and every part in the product is meeting my safety requirements and also the standards requirements. And the other one consideration is reusability. Finally, the cost also very important, DFC, and dematerializations, how I am going to dematerialize at the end. Packaging, we can say, think it is a smaller thing where I am just covering the product with the papers, but packaging also very important because this is the key things damaging the environment frequently, and the technology adoptions. Technology that I am going to select for my product can be able to upgrade for the future expansions. So simply all these Ds are very important for NPD process. Here we can see these two things are very, very important from 2023 onwards, the REACH and ROHS. All key parts that I am going to introduce in the NPD should meet the REACH and ROHS requirements, whether the materials are eco-friendly, whether I selected the right recyclable material for the packaging, whether my resources are sourced responsibly, or I'm dumping more resources, or whether I can be able to use the existing pipe products or recycled materials instead of selecting a new material. So all those things are important for selection of materials for the sustainable, and also the manufacturing process. I'm using the right manufacturing where minimizing the resources to bring the product at the end from the start of assembly to end of line testing of my product. Also transporting the material to customer end or the product to customer end. It is not only the transporting of product and also the transporting of spares and the servicing aids. Everything need to be considered. Finally, how am my product going to use in the customer end without affecting the environment? The best example is automobiles, where we can see the emission standards, which is every frequency of 2 to 3 years, the government is upgrading the emission standards from B1 to B6. Okay, so this is about the product development process, where I need to consider the sustainable. If we see the product development process, each and every steps of the product development process, I need to consider the sustainability. When you considering the product development process sustainability, the key things are to minimize the resource usage as well as the wastage of material during the development stage. The important tool that engineers accessible and adapt for NPD is computer-aided engineering. In our sequential process from the concept design to final release of the product, These red highlighted steps are very important, where this is the key steps where the product modules and the product solution meeting and the meeting of statutory requirements are validated. So these things can be done through virtual by the use of computer-aided engineering. That is the objective of considering the CAE for sustainable development. How the computer-aided engineering plays into role from the idea screening to market launch. If you take the detailed design and development, this is the more time and resource consuming area where we can play with our computer-aided engineering and visual prototyping to minimize the time, resource, and wastage of prototyping, the major resource consumption during the development. If you take any NPD, even if you take a smaller product that may have many elements of the mechanical or electrical or electromechanical components. If you take a small piece of material, the design arriving will be like a selection of arbitrary concept and finalizing the concept through calculations, then going for the CAD and simulating the things and finalizing the concept, whether it is meeting my factor of safety requirements or not, then it will be go and sit into the whole product or in the systems. From the start to end, there are many steps are there. In order to use our technical calculations, if you bring into the computer-aided engineering, the time, resource, and the validation material and prototyping can be considerably reduced. That can improve or make more confident on the sustainable delivery. If you take the solutions available for our engineering problems are either theoretical or analytical method, or the experimental procedures where we are doing with the lab setup, and finally the numerical. The numerical process are computer-aided engineering. Each process having its own positive and negatives. Theoretical, it's a classical approach, formula-based results, accurate results, but the consequences are we cannot be able to use this theoretical analysis for our practical problems. Even though we have ready-made and tailor-made equations are available, we cannot adapt those equations for bringing the practical solutions, design outputs. That is the drawback of using the theoretical. Experimental, for each cases, we will not be able to go for experimental. This is the key impacting area in the sustainability. If you use experimental procedure for all NPD, we will able to use, or we will potentially affect the environment by wastage of material, resource, as well as the cost, and also the time, and consequently that will affect the economic sustainability. Alternatively, if you use computer-aided engineering, this is combination of theoretical as well as experimental. In numerical procedures, we can obtain solution for all the practical problems. Sometimes without prototype also, we can able to bring the final product. All real life complicated problems can be adapted. And one more thing is we can use full scale simulation, whether it is 1 mm or 1 centimeter. It doesn't matter for the visual prototyping. Also, we can use for hazardous and all kind of environmental considerations we can able to consider in the 24/7. The pressure, temperature, humidity can be considered in the computer-aided simulations. Because even if you perform the thermal testing of a product in the afternoon, we cannot say the reliability of that product if it is sold in Nordic regions or in Europe conditions, because there may be changes in the humidity and the environmental conditions. Those can be eliminated in the CAE evaluation. Even the boundary layers effects are easily included in the designs. The drawback, results cannot be believed blindly just with visual prototyping. So 1 or 2 prototype validation is must based on the product, whether it is automobiles or whether it is other consumer products or whether it is mobile phone development. Based on the nature of product, the number of prototype can be limited. Finally, it should be verified through hand calculations, because for all the inputs, it will provide a color plot. Just with the color plot, we will not assume it is right and go for the regular production. The background information needed for applying the CAE effectively is the mathematics and our key subjects like heat transfer, applied mechanics, fluid dynamics, strength of materials. So the key purpose of introducing the CAE in NPD for sustainable output is it will give a lot of flexibility for validating the concept in the start of the NPD process. Sorry, start of the development, where virtually you can develop many concepts and you can apply the loading conditions and the customer end boundary conditions, climatic conditions, everything you can include in the simulation, and you can see the consequences of different conditions on the product performance. And finally, you can select the right output for your NPD. So what is CAE? CAE, it is using of computers to solve our practical problems through equations and boundary conditions. It's broadly, we can say structural and fluid heat transfer like FEA and CFD. All are based on the basics of our mathematical equations for the applicable problems. There are many tailor-made softwares are available and custom tools also possible. Ultimately, this method is to solve our engineering problems, which is having a physical background or physical concept behind the problems. Both the CFD and the CAE, it works with key steps like mathematical modeling, geometrical modeling, and material modeling. These 3 steps are very, very important, where we need to apply our studied subjects and the concept effectively to bring down the governing equations, and also how to model this concept in the CAD, whether it is 1 dimensions or 2 dimension or axis symmetric or 3 dimensions, and also the material modeling. In the analytical calculations, most of the time we will limit the material model within yield or ultimate, but in computer-aided engineering, you can extend the material modeling till the crack initiations, or sometimes if it is a rubber, all beyond the elongation also. That is the key advantages of introducing CAE for NPD. How it works, whether it is CFD or FEM, the key thing is, as mentioned in previous steps, like mathematical modeling, that is the governing equations, selection of right equations. Sometimes if we don't have the equations, we can develop the equations by considering what are the forces, influences of forces and boundary conditions, and how it is going to perform, or how it is, where it is going to perform. All those things can be considered, and we can arrive our own equation through mathematical modeling. Once the modeling and the boundary conditions are arrived, we can select the discretization approach, whether it is volume based or area based. Then finally, we can summarize through solving the equations. So all CFD and the FDM all working in these concepts only. This is mathematical equations for your selected problems. Then selecting the appropriate discretization techniques. Once if you select the discretization and apply to your selected equations, we can have the system of algebraic equations. Once if we have the system of algebraic equations with any matrix solvers, finally we can arrive the unknown, whether it may be velocity or temperature or deformations for our problems based on whether it is structural or vibrations or heat transfer. The basic steps involved in is I'm very sorry. The basic steps involved in CAE are like before entering into my CAE domain, I need to list out what is the objective of analysis, whether it is structural or heat transfer or fluid flow or electromagnetic or nonlinear structural. Then I need to go for the physical domain modeling, whether it is one-dimensional or 2 or 3 dimensions. And also I need to consider whether I have to consider all the fillet and the champering and the holes or just a blank model is enough. Then selection of the discretization technique, element and the measures. Then going for selecting the whether it is non-linear material or linear material or non-linear geometry or linear geometry, and also the loading, whether it is steady or transient. Then going for the actual discretization and applying the boundary conditions, we can able to get the results. And finally, the validation is very, very important in computer-aided engineering. Otherwise, always we will get the results, but that will not meet our intended requirements. These are all the different elements of computer-aided engineering based on the physics of the problems, whether it is static or thermal. But the key elements and the key results that can be able to see here is deflections, strains, if it is structural oriented. If it is heat transfer oriented, we can see the scalar parameters, temperature, heat fluxes, and gradients. So once if we are clear on the boundary conditions and the equations and also the load cases, we can apply those things in the tailor-made tool or our custom tools and finally arrive the solutions. Within this CAE, there are numerical strategies we have to follow based on the problems. It's all mainly to minimize the solution timing as well as the resources and also minimize the number of prototypes for the validations. If you say select the axis symmetric options, we can bring down the, actually we are seeing just only the time, but it consequently affect on the number of resources that I am going to use and also the number of systems that I am going to use and also the energy consumption for arriving the solutions. Instead of selecting the complete 3-dimensional volume, I can able to select only the segments by using the axis symmetric and arrive the results. And also instead of using the complete fan or the gearboxes, I can use the rotational symmetry options and I can able to arrive the solutions. And also if we take a radiator kind of modeling or radiator kind of product development, instead of taking the whole model, I can take just one segment or one planar. I can arrive the solutions. Similarly, for translated symmetry also for heat exchangers and all. And one more thing is geometrical nonlinearity. Decision on geometrical nonlinearity in the computer-aided engineering is very, very important. If it is structural mechanics, the geometrical nonlinearity is purely based on the slenderness ratio. There are so many other things are there, but the basic important thing is slenderness ratio. If it is beyond 6 to 7, then I need to go for nonlinearity geometric. Similarly, for the heat transfer problems, we cannot assume that just convection is enough for getting the results. Convection we can get for if your body is cold under normal environmental conditions, or even if I drop in the water, still it is a convection concept. But based on the Biot numbers, we need to decide whether it is a lumped parameter or fully transient or steady state. These are all some of the key things we should remember while going for the CAE. These are other examples where I need to consider the one-dimensional flow instead of three-dimensional. Similarly, if we take nozzle kind of things, instead of modeling the whole three-dimensional model, I can use quasi one dimensions. Here, the quasi one dimension means the surface or the area can be linearly varying. For such kind of applications, I can use quasi one dimensions. And similarly, for area type problems, I can use two-dimensional instead of going for three-dimension. It will increase my computation time and resources. And one more thing is like axis symmetric. If you take most of the problems like cylindrical or spherical, instead of developing all complete three dimensions, I can able to get the results for the extended domain just taking one segment of the geometry. So another one thing is, as mentioned earlier, the repeated or cyclic symmetric. It is not just to bring down the time and reduce the resources. It is also to improve the efficiency. If I, instead of modeling three dimensions, if I model only one fan or only one segment, I can minimize the computation as well as improve the accuracy by eliminating the truncation error. If I use a three-dimension or the complete model, if the number of equation is 1 lakh, then for 1 lakh equations, during the approximations, I may truncate 1 lakh numerical values. Instead, if I use only axis symmetric or cyclic or repeated symmetry, the 1 lakh can be minimized to 5,000 or 6,000. So here the truncation error will be only for that 6,000 elements or 6,000 sub-equations. So in that way, we can improve the accuracy of the results also. These are some of the case studies that we applied for new product development, in the concept development, as well as in the prototype evaluation stages. This is a simple static analysis, but we minimized a lot of time and cost as well as the prototype wastage. This is developed for estimating the cutting machine deformation analysis. And we can use CAE for effectively for estimating the mode shapes as well as whether my system will interact or face any harmonic due to natural frequencies. So if you take, actually this is applicable for all products, but this particular product is for cutting machine development, where my product efficiency and the product output, cutting efficiency as well as the accuracy of cutting is entirely depends on how I am controlling the vibrations, how I am going to consider the vibrations during the development stage. So if I, instead of using the numerical techniques or computer aided engineering, if I go only the prototype evaluation, then I may end up with many prototypes of similar setups, which will impact on the cost as well as the resource as well as the material wastage. I hope the people able to see my videos. Sometimes will only presentations.
We are not able to see the video, sir.
Thank you. So for this kind of validation and development,
Video is
if
not
you
visible,
go
sir.
always with the prototypes, we can see how much cost and the resource and the material wastage will happen. So we can improve the sustainable activities through this kind of visual simulations and come up with final results. Similarly, the harmonic response, not only just the mode shapes, we can also arrive the harmonic response. This harmonic response, not just for my product, we can also consider the transport condition from one place to other place. If I transporting the final product to end customer, what are the consideration I need to consider from the packaging aspects, from the assembly aspects, from the robustness aspects. So everything we can bring it into the input condition for the computer aided engineering, and we can arrive the final shape product. It is like a natural frequency, harmonic, or whether it is a transient or fatigue. For all kind of things, we can able to adopt the computer aided engineering, and we can see before prototyping itself, we can see the results in visually, and we will decide which material, which techniques, with us, what kind of assembly, what kind of fastening techniques. So what kind of torque I need to apply. So everything we can finalize through this CAE results. And also, if you take a certain product which we need to consider the drop and the impact requirements, especially for automobiles. If you are directly going for a prototype after concept, in order to meet the drop and the impact and the pull test requirements, we may need to use many prototypes if you are not using the virtual prototype. Even for a simple product, sometimes it may need to withstand the 1 meter drop or sometimes 1.5 meter drop based on the standards requirement. If you are not using the virtual prototyping, you need to develop first concept, then go for the prototype, and you need to drop. If it fails, again, you need to increase the thickness, again, you need to drop. We will not able to conclude my design will meet the 1 meter drop or 1.5 meter drop. For such kind of requirements, effectively, we can adopt the computer aided engineering and bring the final solutions, whether it is non-linear material or non-linear loading. It is not for just the metals. You can also apply the computer aided engineering effectively for plasticity applications, grip kind of things, non-linear elastic, non-linear plastics, viscoelasticity, hyperelasticity, elasticity for all kinds of material. But the key thing is we need to consider the proper equations for my material modeling. Unless I'm not using the proper equations for the material modeling, again, it will give the visual results, but it will not meet my practical conditions requirements. For that, we can do simple load testings or the material testing to arrive the material equations. And it is not just the thermal or structural, it's also we can evaluate the reliability of the product through fatigue analysis. Even though it is not 100% accurate, still we can consider and we can use the proper margin of safety and factor of safety, and we can estimate the life of my product. This will give the highlight of different analysis and where I need to use and what kind of final end results we will see. A model, harmonic, spectrum, and random type and transient. It means we can able to perform the nonlinear material, geometry, loading, everything with the application of CAE. And if you take heat transfer aspects, we know the three modes of heat transfer, but if you use the computer-aided engineering, the fourth state of matter also we can perform with computer-aided engineering. We have seen one video, plasma cutting. We can able to model the plasma physics effectively, the application of computer-aided engineering. We can able to see how much plasma generation, what is the input needed, and how much depth of cut effectively I can able to use for this plasma cutting operations, and what material I can able to cut, and what is the amount of flow of the shield gases and the plasma gases. Everything we can able to arrive if we use properly the right equations for my modeling. And one more thing is conjugate heat transfer. I can able to combine the two different physics as well as two different material like solid, fluid, solid, gases, everything we can combine and get the solution. If you are not using these techniques, always we need to go for the prototype evaluations. Even if you go for any thermal evaluations with the prototype, we may need to end up with a lot of prototype requirements for each cases, for each fan speed, for each thermal loading, for each current and voltage input. I need to perform many testings. But if you use CAE through virtual, we can able to minimize the design experimentations. And one more thing is, as mentioned earlier, all environmental based inputs we can bring into humidity, temperature variations, from 24/7 environmental variations we can consider in the CAE. It is like fatigue applications along with the modal and harmonic and vibrational. We can also consider the end users requirement and end users perspective, operation of machines and their consequences through fatigue evaluation. This we can see the best example for sustainable development of electronic cooling and electronic chip development for my control requirements. If you take any products, most of the control happen not only with the mechanical, it is also depending on the cross-functional influence like electronics as well as the software domain. We need to discuss and get the right chip loading inputs, and I need to select the fan accordingly to dissipate the heat. If you are bringing the reliable electronic product, we can minimize the wastage, e-wastage especially, which is the key things. And during the selection of chips as well as selection of the elements, I need to consider ROHS as well as the reach requirements. And if we select the proper thermal dissipation mechanisms through fan as well as with the heat sink, my product will extend the delivery of functions for the longer durations, and it will sustain for the longer duration. I may not need to recertify the product after 2 or 3 years. In the start of the development stage itself, if I consider the thermal aspects as well as the ROHS aspects, even if there is a standards upgradations or statutory requirement changes, still I can able to use the same product, same chips and same electronic solution for the product upgradations as well as for the different regions or the countries global standards upgradation. It is not just FEA, also with CFD. We can able to use this numerical simulation for all kinds of process and product industries. Similar to FEA, here also the same steps, mathematical and geometrical and loading modeling. In CFD, in addition to structural, where we can able to estimate or apply the boundary conditions easily, but in heat transfer and fluid flow, it is very, very important to apply the proper boundary conditions. Broadly, it is coming under 4 categories: Dirichlet, Newman, Cauchy, and Robin. It is like, it's nothing but whether my boundary condition is just the temperature or the derivation of temperature, or the derivation of temperature is again depending on temperature, or it is a mixed temperature and derivative of temperature. So this is very, very important, especially for the heat transfer and fluid flow, applying the proper number of boundary conditions. It's based on the highest order of my governing equations. Even if you provide surplus boundary conditions, you will be able to get the results, but it will not match our actual requirements. Along with the boundary condition, if it is transient, I need to consider the time boundary conditions. Similar to FEA, here the selection of physics and as well as selection of the environmental conditions, and so each thing is based on a different concept and the equations, whether your governing equations having time influence, or whether your governing equations having the Reynolds number influence or the compressibility influence, or whether your equations having the material influence. So, and also the different heat transfer aspects, whether it is just heat transfer or the coupling of heat and flow, or sometimes coupling of heat flow as well as with the structural. And based on this, I need to select the equations and apply the boundary conditions. But all these things are entirely based on the conservation laws. These are some practical case studies that we adapted during the product development for one-dimensional and two-dimensional, just to flow as well as flow with the heat transfer. These are all practical examples where we can use the CAE CFD for the flow transfer problems. This one is a magnetohydrodynamics along with the heat flow and structural. The fourth physics, like fourth matter, plasma also considered here. Plasma, I think we know, if we burn the air beyond 500 degrees Celsius, it will start conduct the current. That regions we can say it is plasma. So along with the nonlinear material and nonlinear geometries, here key things are the arriving material equations by considering the conductivity, humidity, and electron transmissions, everything. So if you use CAE for these kind of developments, we can minimize many of the prototype requirements as well as many of the other resource requirements for sustainable product development. Sorry for moving fast, but we have limited time. So we can able to arrive many solutions through this CAE with the sustainable considerations. So even though CAE provides many insights in the product development, the key things are verification and validations. That is very, very important. Verifications, it is nothing but whether my software solved the equations rightly or not. That is secondary things, but the key thing is validation. It is entirely depends on our subject matter, whether I have used the right equations and the right boundary conditions or not. That is the very, very important. And also we have to consider the errors available in the CAE results, both acknowledged and unacknowledged errors based on the modeling of geometric, material, and loading, as well as selection of the systems. So in summary, for the sustainable considerations, the CAE can be effectively utilized and applied for product development at different stages, from the concept development to delivering the product to the customer end. It means concept developments, visual prototyping, selection of manufacturing process, selection of transportation, considering the transportation requirement in the assembly, as well as in the concept of selecting the fastening mechanism, packaging mechanisms. So it will bring down the time, cost, as well as the resource requirement. Alternatively, the key things are we should be strengthen our subject in order to use these tools. Otherwise, we may think that we have results, but that will not match with our actual intended requirements. Finally, the validation is very, very important. Whether I'm using a theoretical or experimental or the numerical, the validation is key things. Yeah, that's all. These are all some of the references we can go through for adopting CAE for the NPD.
Thank you, sir. Thank you, sir. Thank you. Thank you for your wonderful talk. Okay. Session is open for discussion. You can ask some one or two queries.
Yeah, actually, sorry for moving the slides fastly.
Okay.
Just this session will highlight and show how can we utilize the available numerical engineering techniques to adopt in the NPD process by considering the sustainable and sustainability.
Dear all, anyone has some query? If there's any query, you can float it. Okay, we have a time for say one or two queries only. Okay.
Arsha, sir, there is one question in there is one query in the chat box.
Okay.
Yeah, I can answer through this chat box also.
So what is the basic difference between CFD when compared to FEA?
Okay, so the CFD works in the aspect of constant volume-based discretization, and the FEA, it is not a constant volume-based, but FEA is finite element-based. Only the equations difference here. While developing the CFD, I need to consider again the conservation of mass momentum and energy plays key role in CFD, but FEA, it's an equilibrium of my forces.
Any other queries? Okay, sir. Thank you. Thank you, Dr. Paramanandam, sir. Okay, it's
Thank you. Thank you.
Very
Thanks
good
to
talk,
all.
very wonderful talk. Okay. Thank you.
Sir,
Thanks
yeah.
a lot, sir.
Sir, this is Madan Raj.
Yes, ma'am.
Sir, thank you, sir. I am the coordinator for this program. Thank you for your valuable presentation, sir. And also, I will thank Ashwardhan, sir. Also, in a shorter time, he has helped me a lot to conduct a really a good presentation, sir. I am very happy to meet you, sir, in person. Also, I will try to contact you, sir. Thank you. Thank you very much.
Thank you, Manraj.
Yeah.
It is
Thank
my
you, sir.
pleasure.
Thank you, Paramanandam,
Thanks
sir.
all. Thank you.
Yeah.
Participants, please stay. The next is
Okay.
the speaker is ready to, after a small introduction, the next speaker will start his research presentation. At the end of the presentation, there will be a feedback form. Please fill it out. We will provide the certificate soon.
Okay.
Vijaya ma'am is there?
Ma'am, sir, I'll give the introduction about the speaker.
Sendil sir. Sir?
Harshavardhan, I'll give the introduction about the speaker, sir. Okay.
Yeah. Then you can use the start.
Okay. Good morning, one and all. Okay. Our next speaker is none other than our own colleague, Dr. R. Sendil. Okay. To give an introduction about him, we all know that for every 24 hours, sun rays comes and touches our earth. Okay. Dr. Sendil is none other than who works aggressively, who works in detail on the solar energy. Okay. About Sendil, sir, Dr. Sendil is an associate professor in SRM University. Okay. He obtained his BE from University of Madras, ME from Anna University, and PhD from SRM University. He has more than, say, 2 decades of teaching and research experience. He is one of the top 2% research scientists. He was awarded for 2021-2022. Okay, as a top 2% scientist, and he has more than, say, 30 research papers on top reputed journals, of course, related to solar energy and solar energy conversion and storage technology. And he has more than 8 nationals and international awards for research and teaching. Okay. And he has reviewed more than, say, 63 international journals. And that's what he is, a very diversified personality who works extensively on solar energy. Okay. When we talk about sustainability, solar energy plays an important role. So I invite you, sir, Dr. Sendil, sir, I invite you to give a lecture on sustainability. Okay.
Yeah, thank you, Dr. Arsha, sir. Thank you for the opportunity. Yeah, I'm sharing the screen.
Okay.
Arsha, sir, screen is visible or?
Yes, sir, it's visible. Okay.
Yeah. Yes. Thank you, sir. Yeah, regarding our institution, we are having 3,000 plus faculty members and 50,000 plus full-time students across all the disciplines. So this is a overview of the campus. Most of us from here only. Yeah, regarding sustainable development goals, today I'm going to talk something about 7th goal, goal number 7, SDG 7, affordable and clean energy, how it can affect or impact other few goals also. If you take good health and well-being, clean water sanitation, decent work and economic growth, sustainable cities and communities, responsible consumption, production, and climate action. Even some of the indicators of other goals also can be easily satisfied when we are working on affordable and clean energy. Regarding solar energy, we are having major two components, beam component and diffuse component. The beam components are responsible for increasing temperature, the diffuse is also, but when comparing these two radiations, whenever the surface is flat, the total radiation can be useful. We can convert into some useful energy. In case any curved surfaces, we can account only beam radiation, because the beam radiation obeys optical law, so that component can be used for any curved surfaces. Any collectors you are using for high temperature application, that can be considered only beam radiation as the input. So when you're adding these two to the global radiation, whether flat plate collector, water heater, solar panels, everything works under total radiation. So how the SRM is taking part in climate change or SDG 7? Some of the major solar energy initiatives in SRM, just in a few slides. We're having more than 800 kilowatt of solar PV panels are installed in our different roof structure, whether a flat roof or slant roof, even on the hangars. We are having so many places. Each may vary 100 to 200 kilowatt ranges, but totally we are having 850 kilowatts. So these are the aerial view. You can see wherever most of the places, all the rooftops are filled, installed with solar photovoltaic panels. So regarding the power generation, we are adding every year some, increasing the capacity. So as of now, we are having 865 kilowatt capacity installed. Our target is 1000 kilowatt. So we are working on that. Then regarding the power generation, we are sharing around 20% of the energy produced by the solar photovoltaics. Whatever the campus energy percentage, whatever how much you are consuming, about 20% is done by through by solar PV. These are other solar photovoltaic power plant we installed in Tirumala Tirupati Devasthanam. So that also generating power for more than 7 years. Then another one, the steam generation. We are using solar disc collectors for producing steam that is used for cooking and other purposes in hostel. So regarding the cooking, we are able to save 5% of the LPG consumption of the year when you're using the solar energy for the cooking. Then we have the different certification for well-maintained plant and all other many certificates from MNRE from the God of India for regarding the well-maintenance of the plant. Then regarding the main topic, how the energy storage is useful for solar collectors. So when we discussed about different collectors, some collectors are flat plate. It is using global radiation. Some collectors are having curved surface. It is using beam radiation. That regarding the energy storage, we can use any material, whether water is a storage material as a sensible heating. It can raise the temperature, can store energy. Sometimes phase changing material, if you use paraffin wax, for example, it can melt during melting. It's storing energy around 300 kilojoule per kg of phase change materials. Then some may be changing phase at the same temperature, so it can store more energy. It is having more enthalpy. So when compared to latent heat storages or centrifugal storages, latent heat storages are little it is a compact one. It can store 10 times more energy in a small volume. So when we talk about different type of storages, storage can be separate from the solar collector, or it might be integrated into the solar collector. So sometimes can call separate or can be integrated. When you're integrating, you can reduce the losses when it's transferred from collector to storage. So this is the layout. It is showing a separate storage. Either the circular ones, different color set source as a different temperature data. So this is a separate storage. It is no, it is not in embedded in the collector. It is separate from the collector. It is called discrete storage. Then if you take this solar collector, below the absorber plate, we are storing the energy using phase-change material or even centrifugal medium or different media. So these materials store energy at the collector itself. So during the daytime, because whenever the peak radiation, it can store energy in the collector. Whenever you need application, you can pour the hot, cold water, you can attend the hot water. So this is storage integrated. That is the integrated collector storage. Then before going to apply any material in the real time, in the real application, we need to test at the lab level. So we are having the small test rig. We can have the storage medium as a bulk medium, we can pass hot water because with this heater is acting as the simulating like a solar water heater. So hot water goes to the storage. What are the combination? How you are making uh, fast melting or fast charging or storing energy at the faster rate? You can study at the lab level before going to deploy in the real-time outdoor system. Here, the pacemaker metal kept with the paraffin wax. It's kept inside the acrylic container. When we are changing the orientation of the heater tube, the hot water is passing through this one means it is hot water from the solar collector is passed through the storage. So it can melt the PCM, but there is insulation not shown. The insulation removed here. It is so for the easy visualization we are showing here. So when we are changing different type of the copper tube passing inside, whether center or a little below, eccentric or inclined. So different orientation we can change, we can test which is melting faster. The reason may be when the hot water is entering at this one end. So that time that may be more temperature distribution or more heat flux. It can melt faster at this region, but when it goes to other end, it may take long time to melt because the water is losing heat while passing. Then once it's completely stored, I mean, paraffin melted, it means stored energy. Then whenever our requirement, maybe evening time or morning time, there is no sun, we can pass the cold water through this. We extract the heat, whatever stored in that one. So that time, the whatever the material is now becoming liquid, it becomes to solid again. So next day we can store during daytime. Then evening time we can extract the energy for our application. So whenever if you say any application, any solar energy system, the maximum energy at minimum time, that is the mantra. So we have to store more energy at the minimum time. So we are using the faster melting rate means we can have more energy stored at a little lesser time. This is one of the work. Then when I told you when the water is entering hot water, here more temperature distribution, here the pH materials are melting faster, but far away it's not melting at the other end. So we can use the small fins, smaller height fin, but here you can use longer one, you can melt faster at the end. So this is the one variation. So any thing you can do at the lab level, you test it, then we can go for real-time outdoor applications. So these were different, the uniform height and variable height pins. That work has been published in a journal. Then another one, whenever we are changing like the orientation, center, then eccentric, incline, that also have impact. The incline mean how it can melt faster. Then comparing this is taking 2 hours, this is taking 1.5 hours, this may be 1 hour 15 minutes. That we can say this is the better configuration. So that work also published in this journal, in the Taylor Francis channel. Then if you say vertical storage, the center, the passenger is not melting fast because the solid piece is almost settling down. So this dome structure is forming. So whether we are using a small inside coil, a conical coil, or again small helical coil, we are able to break this structure quickly. It can store faster rate because it is taking long time. It means we are storing long time in the heat loss also goes out. So we are charging faster, it is better. I mean, charging faster better means whenever the radiation is around 10 to 11 to 2 o'clock peak time, that time can get a high temperature water as output. That can be passed through the coil structure. We can store more energy in the passage material. So different coil structure we have tested at the lab level. So that has been published in few journals. Different geometry, how it is affecting the patient performance. Then different enhancement techniques like nanoparticles, how it can improve the melting rate. Then another one, if you're using a conical coil at the center, because the conical shape is forming at the middle. So when you're using a conical coil structure at the center, it can break the solid PCM faster rate. So this also we publish in Fancy channel. Then instead of conical structure, we have the helical structure again, the longer helical coil at the outside, then inside also small helical coil. Then that work also we have published in a storage journal. So it means when you are melting faster, it means we are storing faster rate. We are charging the energy storage, thermal storage in the faster rate. It means we are able to store more energy at lesser time. It reduces the heat losses because you're storing a longer period. It means even the heat losses can be more. So we are reducing the heat loss by means of storing at the faster rate. Then in the horizontal also, we have single tube we have seen earlier. Instead of single tube, what are the diameter, what are the surface area, we can make into small tubes of 6 number, then how it can melt the patient material faster? Because it is melting from one end, from the hot water, it is melting at the melt from liquids keep on increasing. The hard PCMs are at the periphery. Same way when you're passing cold water, here the PCM is become solid, it is losing energy to water, then you get energy coming from the other end. So instead of a single tube, we can have the multiple tube. So many configurations available, 2 tube, 3 tube, more, even more on the bottom, less like that, because the solid is almost settling, slightly coming down. So we can need more heat transfer area at the bottom. So this type of study also we done by the simulation. So it is a single tube, then it is a multiple tube. So how it is melting faster when compared to this one? These times are given here. Now see the logic, because the single area, but here we are making small. So it is localized melting. It is melting here and there. Then these liquids are mixing. They like that. So the melting is better when we go for multiple tubes. But the only thing, when the construction wise, the design of heat exchanger may be little complicated when you're going for more tube, because the leakage and all other aspects. Other than that, the thermally it is better. So this work we have published in energy storage, Journal of Energy Research, Wiley publication. Then if you see, when we not see about horizontal system is a bulk PCM storage system, the bottom is solid settling, whether the vertical also bottom solid, same way horizontal. When we are having 3 heat transfer tube, one at the bottom or maybe one at the top, so which is melting faster rate. This study also we done by simulation only. So how these configuration, because like the smaller one is down or 2 is down. So when we say the solid, the solid PCMs are more at the bottom, so we are having more not tubes at bottom, it is better than single tube. So this work also we have published in LCY journal. Numerical study on melting of patient material in a horizontal container using multi-heat transfer tubes. Then the disc collector, this is one we are using, around 37 numbers we are using for steam generation in hostel. Many of the teams are working on this solar collector, how to design a effective solar absorber, because this is 16 meters per area, this is a 0.126 meters per area. When you are modifying the fluid flow path or different mechanism, how it can convert faster, because when the water is entering is 30 degree, when it's leaving at 60, it is better. When it's leaving at 40, okay, we need to modify. We get to modify it. When it is leaving at 80, it is very good. So here our design on the observer only, we are changing a different design, how it can impact or it can extract more energy at the shorter time. So this is a schematic layout of the system. So observer only we are modifying. For that we are supplying the water through pump. We are measuring the flow rate. We are varying different flow rate. And then we are controlling the flow rate through the valves. So this is the reflector. It is separate. This circuit is separate, but it is always focusing on this one. It is by actually we are tracking the sun, because the sun movement is east to west daily. Then it little above our head or maybe down during the seasonal variation. So during June, it is sun is almost above our head. During December, it is below the near to horizon. So that time also we have to track the this north to south. That is the seasonal tracking. So these designs I will discuss how we are using energy storage as an integrating inside. So the temperature distribution on the surface, it is not uniform. It is higher at the center, lower at the middle. So we need here more temperatures available, heat flux, here less heat flux available. This is the actual design. The water is entering. The fins are behind the surface. Behind this surface, fins are there. Water is entering through the high temperature. From here to water, the heat transfer take place. This is the basic design or the available one. Then we are changing the curved baffle or like a fin structure. Water is entering at the periphery. It is coming to next one, then our next level, next like that, the inner circle, because the temperature distribution is higher here. So water is entering initially here, it is gaining temperature delta T, then again more like that. So these two designs are tested. We compare, all the designs are compared with the basic design. Then another one, here the same one, but the periphery, the inner surface, we have the another region, there we kept passage material, because it may act as the one more heat transfer surface. This process, from the horizontal, when we talk about the paper, perpendicular to this page or paper, the radiation is coming from the reflector. But this one, it is originally from this surface also it is going to the water. So it is how it is heating better than this one. That study also done. Then same way, the modification of this one layer passage material, one layer water, another layer passage, another water. Like that, we have modified this circular flow path. First is water, then passage material, then water, then passage material. In between, there is a passage, water can pass through next level. Finally, water leaving at the center. This is the one more study. Then another one, instead of water is flowing here, we kept the fin, we filled the passage materials, chemicals here, we completely welded behind. So this one like a heat battery, you can charge it within half an hour. It can have very high temperature. It can be taken to some other place. On hot water, or you can put these are one or two, no, this one in the tank. You can get the hot water like that. It is a transportable. Just you can mobile heat battery. We have done some experiment. Then all the combination here we have the circular region. It is filled with PCM. It is like a fins, like a no, protruded cylinder fin, that type of structure. Then we are having the baffle. So water is entering at the two entry because the one which is entering here, it is going through the one passage. It is for passing over the cylinder. It is the passage material that energy storage. So both the side it is coming. Then finally it is mixing together. It is leaving out. Here two entry, two inlets and one outlet. So these different structures we have tested. When many more is ongoing. This one, different no, alternative arrangement. The passage materials come entering, the water is entering the first layer, then any chemicals, then like that. So this layer, this work is because this receiver is acting as the source. Whenever 10 minutes there is no radiation, the output almost remains same. It is not affecting. So that type of storage also it is inside the collector. Is the observer that we have kept the passage material inside. So this is acting as a buffer storage. Whenever 10 minutes or 5 minutes there is no radiation, the observer is not suddenly coming to low temperature, but it is having passage material at a high temperature. It is capable of providing heating. The only new thing here, I mean, you have to remember the periphery low temperature means we have to keep the melting point around 100 or 120 at the periphery. At the center, we are reaching around 200 degrees Celsius. So we can go for 150, 160 degree melting point passage material. So selecting the passage materials for appropriate places or region is important. Then another one, I told just we are keeping passage material inside. We filled like a heat battery. We can carry to some other place. So that one also it is published in Elsewhere journal. Then another one, I told them fin type passage material filled containers are there. Then water having two different flow direction. Because if you're circulating, it can have more circulation, I mean more distance traveling, more pressure drop. So we're having made into two inlets, and that also published in Hydrogen Energy. These are Elsewhere journal. Then patent published based on the before previous work. Then regarding solar cooker, box cooker, already the box were having blackened pots. It is a metal pots, aluminum or stainless steel based. Instead of the plain surface, we have given some fins over there because fins mean it can increase the heat transfer. So we made different height fins, small, medium, and long fins on different parts. This is tested on outdoor. This is our mechanical B block rooftop. So that work also published last year in Renewable Energy. In experimental investigation of the thermal performance of box type solar cooker using finite cooking method. Whenever using fins, it is increasing heat transfer. It means instead of taking 2 hours, 3 hours for cooking, it is able to cook within 60% or 70% of the lesser time than that one. So the fins are good, but the only thing we need to provide a handle which should not affect the people who are handling the vessel. So that other arrangements are social, other aspects are there. Then here solar photovoltaic cooling. So normally the panels kept outside, outdoor. It is getting heated because the beam radius is not good for solar. It is visible lights are sufficient for generating electricity. When we are adding a beam radiation and all, it is heating. It is going up to 60, 70 degree. So whenever temperature increases, the current flow decreases. So to avoid that one, many studies are done by several people in our university also or outside also. When we are passing the air below the panel, then same way we are passing water also in between. So here hybrid water as well as air both we sent on one panel, both are identical. But here the other panel, the first one left side is plain, nothing, no cooling effect. naturally whatever the air, wind velocity over there, that is getting cold. But here we are forcing water, we are forcing air behind the panel. Even in the behind, we use the passage material as a thermal storage packet, small container. Even inside the container, water is passing. The outside the container, air is passing. So we are using the heat energy for heating water as well as air. This is a simultaneous production of heat as well as electricity. This one is schematic. The second circuit is having airflow circuit, water flow circuit, then begin passage material packets. But other one is nothing. When comparing both how it is electrically performing, thermally performing, this one is getting more energy because of heat energy as well as electricity when compared to this one. So this work we published last year in these are different methods how to cool the solar panel. And then what are the temperature measured by using optical sensor, how we can measure the temperature of the panel. This work also published in Elsevier journal. And then another one, optical fiber journal, also we have published, because how we can use measure the temperature of single panel or multiple panel at the same time accurately, how we can suggest the solution for that, the cooling method for that. This is a machine learning based Bragg rating as well as machine learning based solution for that. Then another one, how we can convert solar panels into bi mode, like a hybrid mode. Then this work, whatever I told in the simultaneous production of heat and electricity, that work is published in Energy Conservation Management last year. Then PV immersion cooling. Sometimes we can cool the panel by immersing, not completely inside the water, just 10 mm, 20 mm like that. It can have the cooling effect, because if you go down, it will not have lighting effect. It won't produce electricity. So like that small height, how we are varying the immersion, the panel can be cooled, or we can get some good output also. So that work also we published in Asperger journal. Then another work, here we are using passage material, thermal storage. This is solar water heater come air heater. So this one, even a flat plate solar water heater is made for hybrid mode. One is for producing hot air and producing hot water. This tank is long, hot water tank. This is the blower is here. It is insulated because to avoid heat loss, because this is operating at low temperature around 60-70 degree. So we have provided insulation for both. So this system is producing hot water as well as air for space heating. So single system, small area, it can produce both output. It can be useful for buildings required hot water as well as hot air in cold climate. So this work, similar work regarding the solar water heater, how different enhancement can be possible. That work is published in Solar Energy Journal. Then whatever the combined heating and air heating and water heating, just I told the previous slide, that simultaneously heating and getting hot water and air, that work is published recently in Operational Engineering. Then regarding solar water heater, the tubes are kept inside the collector. Sometimes instead of tubes, you can go for a small baffle. The water can have some serpentine, flow. It takes long time inside the collector. How these two collectors, the normal collector as well as a baffle collector, can perform. That also we tested. Here pressure drop is more, little pumping power is increased, but the thermal performance is comparing these two, this is better. So this work we published in Springer Journal. It is called a serpentine flow channeled flat plate solar water heater. Then inside the water heater, the tubes are there, copper tube. When water is flowing through that one, it can faster. It can, whenever forcing the water through pump, it can flow easily from one end to another end. But to stop that one, it can make creating turbulence or mixing. You are making more residence time, because normally heat transfer takes mainly based on temperature, turbulence, time. So if you are making some turbulator, some disturbance inside the tube, these are flow insert. This type of shape we are keeping inside the water tube. So because of this different type of twisted tube, a single slate, then double slate, this and all, it is disturbing the flow, but same time it is increasing the turbulence. So because of that one, as I told, time, turbulence and temperature is important. Temperature already there. So we are making more time, more turbulence. So this work is published recently in Springer Journal. Experimental performance dynamics of flat plate solar water heater using straight and twisted flow insets. Then another one, the single copper sheet we cut at one place. One we are tilting this side, other one is other side. So like that, this is a copper thin sheet we kept inside the copper tube of the solar water heater. So how this is creating more disturbance. It means more turbulence. So this is improving the heat transfer. Then how it is compared with the plain one. So the tube without any insert, then with the this insert. We are calling it the bifunctional. The reason is this is kept on the inside the tube. It is acting as the fin, then this tilted surface acting as the deviator. So it is acting as a deviator as well as the fin. We are calling it the bifunctional, two functional, bifunctional for insert. So this one we published recently. A experimental study on thermal performance of flat plate solar water heater with a bifunctional flow insert. So why I'm saying this no application as a proof, it can be easy enough to remember or how we can change the modification. Even you can see visualize all are mostly experimental, even simple modification, but you are able to store more energy or convert more energy at a lesser time. So that is the objective of all the works. Then here air heater. This is called simultaneous test. It means one, it is modified with the circular coil, other one is straight tubes. So both are filled with glycerin or both are filled with paraffin wax. So we are at that test sensible heat medium, latent heat medium, and simply when you're testing both means at the same time you can get the radiation. Both the collectors are same size, input is same. Then wind velocity at the same collector on the surface, both are same. Then ambient temperature, hygrometer is there. The moisture as well as ambient temperature can measure using the weather station. This is also done in our mechanical B block. Here we can compare both the things simultaneously. So that is the advantage. It means this is different modification. This is another one. Both are tested same time in same environment. All the input conditions are same. Even the flow rate, whatever thing same. How this is performing. Instead of taking this is for 5 days, again this collector for 5 days. Now the simultaneous test method guarantee you simultaneous testing we are comparing. It means we are testing the exam is conducted at the end of the semester for all the students. So when the results are compared, when 5 students are this week, next week, it is not easy to compare. So like that, simultaneous test method is we are normally following for any modified collectors. This is again simultaneous changing of water heater. Here different configuration below the thing. Here also different. So simultaneous testing, we are able to get compared easily because all the inputs are same. Only the output temperature you can see here is 40 degree coming out. Then here is coming out 47 degree. Then if you test for 3 days, then we come to know that which is performing better at simultaneous, same operating conditions. So here these are the two configuration. One is a coiled copper tube. The same length of the copper tube, same diameter is taken, but we cut into equal length. So when you're putting linearly on the collector, the air when you're passing, it like a speed breaker. So the water is going through the disturbance like the ribs. But here it is different. So the other it is concentric one. How these two coils are performing, it is not having any biggest or difficult mechanism to fix it over there. It is simply you can keep it on that. You can slightly paste it. Same way this also we kept on that. These two modifications tested simultaneously. This is a spiral and straight thermal energy storage tubes. One time we used the sensitive heat medium inside. Another time we used the latent heat medium. So regarding the how we can improve the air heater, different enhancements that our case published in an Elsevier journal. Then the spiral and straight tubes. So that work we published this year beginning in Journal of Energy Storage. So how we are using two type of configuration. It is simplest to design how it can do better in heat exchange. So that is a thing. We use the sensible heat medium as well as latent medium separately, not on mixing on both. Only one time we tested with latent heat, another time we tested with sensible heat medium. We filled inside the tube. Then is a parabolic trough collector. Everyone know that one is a curved surface. It is a but of the beam radiation falling and that is focusing on the particular observer. Normally the solar observer is tube, a copper or stainless steel tube. It is surrounded with a glass cover. So this is the normal case. When we modify that shape, so instead of circular, we can go for flat or we can go for curved more number of tubes. So that distance we tested, that also we'll discuss in the next slides. So this is a schematic. So water passes through the observer. This is a line observer because whatever the radiation falling on that, it's focusing on the line. So the line observer is heating the water, whatever the water entry, then what is that water outlet. Then if you are circulating again, you will attain a very high temperature. Up to 100, you can use water. In case more than 100, you can go for any thermal oil or thermic oil. This is the conventional one, a single tube. Then we change the tube into a rectangular channel. Channel having different fins. The water can pass through a like a serpentine, a zigzag flow. This observer is changed here. That study we have conducted on outdoor. Then we compared the output of this one as well as this one. Then next study, instead of a single tube, we made it a small tube. 1, 2, 3, then 1, 2, 3. So water is entering at both sides. It is a two inlet. It is entering the outer tube first, then coming to second one, then third one. It is leaving out. Same way, other side entering here, then next second, then third leaving out. So two entry, two outlet. While outlet is mixing together, it is going to the application or storage tank. Then by entering from the pump, we are making fabricating both the flow rate. It is leaving. It means instead of single tube, we used multiple tubes. Instead of single tube, we used multiple tube, then we tested. So all the cases, whether you are using a rectangular observer like this, or when you're using a multi-tube or observer like this, because this shape, whatever the shape is capturing from the collector, whatever the radiation coming, this only single tube, but we change it into a rectangular channel or and other one. So both we have tested. That results published in the Elsewhere journal. First one, a rectangular channel observer. So this one, instead of tubular arrangement, we start differently. Just we have to try for rectangular channel, how we can perform better. Definitely performed better because the channel height is less, but the water is taking long time to leave the observer. It is having little pressure drop is higher than conventional one, but still it is able to produce more energy or absorb more energy at the shorter time because it's taking long time inside the observer. Because of this is the rectangular channel. The fins are kept over there. The bottom side, the radiation is falling. The water is passing like it takes long time, but because there is more pressure drop, more friction, but thermal performance is better. So we have to optimally design what is the that will break even point. It should not be more pressure drop. It should be optimal in performance as well as this one. Another one, this I told you semicircular, different two tubes and having three bend, two tubes with the three channel. This for this one. There are two inlet, two outlet, but here instead of single tube, that same diameter, almost closer to diameter, we made it to small tubes. So the water is entering here, it is connected here. The blue color is the low temperature, yellow medium temperature, the red shows high temperature for the indication purpose. So that work is published in Renewable Energy recently. Heat transfer instead of parabolic trough solar collector using a semicircular multi-tube observer. Why I'm saying different idea concepts, even it looks easy or simple, but only thing you have to try. We all our experimental work, it is not that much costly, but you are able to test it easily. So you're able to provide some results, good result to the society. With our objective is more energy at lesser time. How we are able to conserve or observe more energy at the lesser time whenever the peak radiation is available around 10 to 2 p.m. or 3 like that. So most of the tests we have conducted evening. So solar photovoltaic systems we conducted morning 6 a.m. to evening 6 p.m. Then other collectors are normally we are conducting 7 a.m. to 5 p.m. or even high temperature systems we are conducting 8 a.m. to 3 or 4 p.m. like that. So wherever different collector we fix a different timing, but even any collector, any high temperature collector we can test morning 8 to evening 5 is sufficient. Whenever you are conducting any flat plate system, you can conduct morning 6 to evening 6 or maybe 7 to evening 5. See, these are the different test rigs available in our solar energy laboratory in SRM Katangaluttur campus. Indoor water heater test facility, indoor photovoltaic test facility. Then this is some earlier photovoltaic cooling using nanofluid, solar steels from salt water into drinking water because we are operating that vapor is condensed, then we are taking the drinking water. Then solar dryer for drying food item because any food items sometimes available in more no demand in market, that time they're getting wasted. So we can dry it, we can use for off season whenever the very lesser things are like where we can use for a food item. So any foods having a high moisture content, we can use a dryer. We can dry at faster rate. The color and quality or maybe taste, everything almost maintained when you are doing in the this type of system when compared to opens and drying. Then this is the parabolic truck collector system. They are having two type of tube, one for oil, other tube for water heating. So this system is having both the thing by fluid system. We can test oil as well as we can test water. Oil it can go for more than 100 degree. It is stable up to 3 degrees Celsius, but water is more than 100 means becomes steam. So we are testing the water for less than a degree in this system because this is not steam generation because the standalone lab level test rig. And this is a small disc collector of 1.2 meters per area. Here a cooker is there. The students are doing project on that one. They're using passage materials inside that one. It means after cooking the food, we can keep inside the box. It can retain the more time, even 6 hours, 7 hours, it is in the warm condition instead of getting cold when you're keeping outside. This storage based cooker capable of cooking the food and retaining the temperature for longer period, because the more temperature higher mean it won't deteriorate easily. It take long time. So like that, this is a small cooker in student projects they are doing. Regarding okay, this is how many publications I have made based on that energy storage as solar. As of now, I'm having 84 publication scopus. Then maximum impact factor 16, average is 6.2. Then these are the statistics of scopus value. Then thank you. Any queries you can ask us, we will discuss.
Any queries? Or any clarity, participants? Any questions?
Yeah, one thing,
Tell me, sir.
regarding the energy storage, the reason for using in the collector, whenever our requirement, normally if you see hot water you need in the morning, but the hot water is available around 2 o'clock or 3 o'clock. So the load and mismatch is there. So whenever our requirement and the system output both are not matching, that's why the energy storage coming into picture. We are dealing only at thermal heat storage only, not electrical storage in this presentation. How these storages are capable to postpone the solar energy available daytime, the nighttime your heat requirement is there, we can go for energy storage. So that is the advantage of using energy storage in the collector or maybe outside the collector. So the thermal systems are normally storing the energy when it is available plenty or available maximum. Then whenever the application requires, maybe nighttime or maybe early morning, we can extract the energy from that. So that is the role play of thermal storage in solar energy system. It not only for solar energy system, even you are having a massive engine, it is running a diesel generator, you can store some energy from that exhaust, that stored energy from the energy storage material that can be used for hot water generation. So it is not only for renewable system. These renewable storage can be applicable for any type of heat system. If you take the boiler, if you take a glass industry, there we are having around 2000 degrees Celsius we are heating, we are melting the glass. Then we are making it to tube or other incandescent lights or maybe other CFL, whatever the lights we are making, a different container or any other thing, any domestic applications we are making. Then that time that flue gas from the furnace, it is leaving at around 2000 degrees Celsius. So then we're using a regenerator, recuperator to preheat the air, it's coming to the furnace. So where whatever the heat loss is more there, because this is a furnace industry, because they're using the fuel, liquid fuel or gaseous fuel for fire, melting the iron, a glass ore, then they are making the product. So that energy leaving from the furnace or from the boiler, it is having very high volume of heat output. So wherever you can use thermal energy storage, we can store the energy instead of just leaving to atmosphere and responsible for climate change. So if we are conserving energy for some other application, whether hot water or steam generation, whatever based on using energy storage, it is not only limited to renewable system. It is applicable to any conventional energy utilization or any in the industry, we can conserve by using thermal energy storage. So that point I want to highlight. Here, whatever the discussion I made, how the solar energy collectors are operating, different collectors, whether a solar photovoltaic, flat plate, water heater, air heater, steam generator, how we can interpret energy storage system in that one. So that study, I want to discuss something, just like a glimpses. I'm not telling this is the pressure range, this is the value range. I did show any graph because in-depth technical is not required, because whenever we discuss, the idea is important. How we can improve existing system is important. That it only makes you sustainable. So the solar collector we are using photovoltaic, when is the end of life, we can change into water heater or air heater. We can use it for again 10 more or 15 more years, because initially the solar photovoltaic system is working for 20 years or 25 years. Then we are extending the life for 10 more years as the solar water heater or air heater. Like that, the sustainability is important. So that's why these, whatever the inputs, whatever the idea, whatever possible in all the collector, existing is working well, no doubt in that. But still, we are working for improving the performance or making lesser cost material or less complicated design, easy operation. On shorter time, we can finish your task. So these are objective when you're using for thinking of alternative design or alternative, adding any storage with any solar collector. So these are the viewpoints I want to give. Now you can ask any questions or any doubts, clarification. You type in the chat box or you can directly open the mic. Hey, anybody want to clarify or any doubt regarding energy storage? Because I did go detail about different storage. Sensible means you can use pebbles, steel, anything. Then energy storage passage means paraffin bags, high temperature means salt hydrate, nitrates you can go for very high temperature with the power generation. Like that, the metrics are different. You can use for any application, not an issue. But only thing, when you're selecting any energy storage material, it has to store more energy in a small volume. So the energy storage density of any material is important. Then operating temperature. When you want 60 degree hot water, then you can use select a passage material can melt at 70 degree or 65 degree. You can store near to that, closer to application temperature. No need to store for 100 degree. Then because 100 degree means outside temperature 30 degree, easily can drop. You can lose the energy to the ambient. So we have to store the energy closer to little 5 to 10 degree above the application requirement. So you need to bother about the melting temperature of the energy storage material or operating temperature. When you're taking a temperature 60 degree melting point, then it can degrade 90 degree, but the application sometimes randomly can go 120 degree. So you need to change the material. It should not have the worst case temperature should not be there. In case worst case temperature 130 critical temperature at maximum possible, then the PCM or energy material you're taking, it is stable. It should not deteriorate up to that temperature. So it means it could be stable up to 150 degrees Celsius, because even accidentally it won't reach 150 because it can maximum possible is 130. So the energy storage material is safe. Otherwise it become vapor. It can it can damage the system. It may explode. So it should not take simply any material to any storage. So the maximum possible temperature, like a factor of safety, you need to bother about that temperature. So the system can maximum go up to 500 degree. You select the material, it can melt at 40 or it can melt at 200, no issue, but it should be stable beyond 50 or 500 also. So the stability is important. A lower operating point as well as a higher operating point. These two are important whenever you're selecting a material, because the temperature and enthalpy is important. More enthalpy at the small volume and small per kg means even the container size, the design of heater size is very small, compact. We can easily, we can accept. So the bulky storage mostly they won't prefer, but smaller systems are always preferred. So these are the things when you are selecting a passive material. So many types of materials are there. Even it can start from minus degree also. Even cold storage we can use. Room temperature we can use. We can go for high temperature. We can go for steam generation. So many materials are available to store energy in the real-time application. So whenever you have to choose the application, what is the temperature range? So what is the requirement temperature? All the heat output required. So all the things you have to keep in mind when you are designing or when you're interpreting a PCM material. Here, whatever we have done, we are doing at lab level. We are testing what is the thickness of the PCM melt faster. Then the thickness you are using in the solar collector. Now directly we are using. So small experiments we are doing the lab level, we get familiar with the passage material, how it is performing, how it's charging. Sometimes it will not raise the heat. Then what to do? Then we have to pass the tubes inside that passage material. Then it is releasing heat a little faster. Like that, we are testing at the lab level, small experiment. Then we come to know that, okay, this is better, it can perform outdoor. Because when you're keeping it outdoor, there may be a lot of complication because there is no parameter in your control. Sometimes today, no radiation, sometimes high radiation, even raining, so many seasons are there. I mean, so many variations are there. So we will not able to get good result out of that. So we need to get it familiarized. You can make it a optimal design at the lab level. Then we can go for outdoor. So this is the experience what we had by doing different experiments.
Sindhu sir.
Yes, any questions you
Yeah,
can please type. Anybody you can type or you can open your mic and just you can directly ask us.
Sir, very good morning, sir. This is Somasundaram, sir, from BTech, sir. Sir, it is very useful session because we have the subject of thermal energy saving system we are studying in this semester. So it is
nice.
very helpful and useful to us to review our subjects and syllabus, sir. Very thank to your this thing and all of our lecturers and senior professors, sir. Thank you, sir.
Yeah, thank you.
Vijaya ma'am.
Yes, sir.
Ma'am, கேக்குதா?
Shall we? Yes, sir. Can you hear me?
Yes, madam. Carry on.
Yes, sir. I thank Dr. R. Sendil for his wonderful lecture and presentation. Today, on behalf of sir, shall we give a vote of thanks now?
Ma'am, not audible.
Any other queries? Shall we?
Yeah, ma'am.
Anybody, any students, other students or any
Other students?
other participants?
Participants, please fill up the feedback link for this certificate, for the e-certificate.
Yes, ma'am.
Any other queries?
Okay, ma'am, we can.
Okay. I thank one and all for your participation in this 100-hour IITNSC Techno Carnival. So this is conducted on behalf of this Tamil Nadu IEI State Center for Asian Records. And for this, I just very much thankful for the two resource persons, Dr. M. Pramanandan, Senior Engineering Manager, and Dr. R. Sindhil for their valuable presentation on the sustainable development of the nation, the role of engineers. So that's the theme of this session. And Dr. Pramanandan, he presented about the role of computer engineering for a product sustainability. And Dr. Sendil presented about thermal energy storage for solar collectors. Both sessions found to be very useful in terms of attaining the sustainable goals. And I thank all IEI State Center as well as Katangulathur members for organizing this event, and also all fellow members from other IEI local centers also for participating in the event. I thank our head of the department as well as Katangulathur chairman, Dr. P.T. Ravichandran, as well as Honorary Secretary Ma'am Dr. S. Dhanalakshmi for providing us a chance for organizing this event. I thank one and all for your presence, and I kindly request you to fill up the feedback link for your e-participation certificates. Yes, sir. Thank you very much. Thank you, one and all.
Thank you, ma'am. Thank you for
Yes,
your vote of thanks. Thank you for the participants and also the participants from IEI. Thank you very much.
Yeah, thank you, Madan.
Thank you, sir.
Thank you, sir.
Very much.
Thank you. You can wait some time, let them fill the form, then we can proceed.
Yeah, okay. So sharp 12, we can wait for 2 minutes.
Yes. Then you can start recording also. Yeah. Thank you.
Okay.
Thank you all. Yes.
Wish you all happy Independence Day. We are in the 75 years of celebration. Wish you all happy Independence Day.
Yes. Thank you, madam.
Thank you. Okay, thank you, participants. I'm going to end up the meeting. Thank you.